Hello students, today we will be studying chapter angles. Alright, so again before going into the sums, we will discuss a little bit about the chapter angles, what we will be going through in this chapter, as well as the different angles that you all need to know before you solve the different questions from this book. That is the same book that I have been using for all the chapters, that is Essential ICSE Mathematics for class 7, right? This is the book that I'll follow. So before that, let me dive into the concept of this chapter. All right, so first we'll study the different types of angles. Different types of angles. All right, different types of angles. Now what are the different types of angles which are important for your class 7 examination point of view, as well as that are present in this chapter? Right. So first of all, we'll go through the first angle, that is right angle. Now what do you mean by right angle? Angle which is equal to 90 degree, which is exactly equal to 90 degree, is known as right angle. All right, now next, after right angle, you will find acute angle. Now what is acute angle? Angle which is less than 90 degree, which is less than 90 degree. Angle which is less than 90 degree. All right, now the third type of angle is, I'm just going through roughly. All right, so this all you need to keep in mind. You all have been doing the types of angles from class 6 previously also. You all have done this, so it's just a revision before that. So now the third one is your obtuse angle. Right, now what is obtuse angle? It is greater than 90 degree but less than, greater than 90 degree and less than 180 degree. Greater than 90 degree and less than 180 degree. That means any value. So the minimum, what is the minimum obtuse angle value? 91 degree. And what is the maximum obtuse angle value? 179. All right, not 180, 179 degree. And now the fourth one is straight angle. What is straight angle? Equal to 180 degree. So exactly that is why obtuse angle, what is the maximum value of obtuse angle? 179 degree, not 180. That is why the constraint is less than 180 degree, not less than equals to. If it was like this, less than or equals to, that means this would have been equal to 180 degree, but it is less than 180. So maximum value of obtuse angle is 179 degree, and straight angle is exactly equal to 180 degree. All right, so now after straight angle, reflex angle. Greater than 180 degree and less than 360 degree. So now the next one is reflex angle, which is greater than 180 degree. So what is the minimum value of reflex angle? 181 degree and less than 360 degree. So what is the maximum value of reflex angle? 359 degree, 359 degree. And now sixth one is your complete angle. complete angle. Now what is complete angle? I hope you all have guessed it, and most of you all have guessed correctly, right? Which is equal to 360 degree, which is equal to 360 degree. So this is your complete angle. So these are the different types of angles, 6 different angles that are there, and you need to keep in mind, note this down because you will be requiring this. All right, and apart from this there are few other angles which I'll discuss again. Okay students, so we have discussed the different types of angles. Now again the new one that you will be, this all angles you all have gone through, right? This all were type of revisions. Now there are new kind of things that are coming which you all need to learn. The first one among them is adjacent angles. Now what do you understand by adjacent angles? Instead of explaining it theoretically, I'll explain it practically with the help of diagram, right? That'll be more clear to understand and to visualize. So for example, this is an angle and this one is cutting this angle, right? So for example, A, B, C. The angle was angle A, B, C. The center angle is always written in between. The angle that you want to consider is always written in the center. So I am talking about this. So for example, now this was the angle ABC. So if I want to consider this angle B, I have to write it as angle ABC or angle CBA. Take a note that angle B, whichever angle you want, that is always written in the center, and the other two vertex you can use whichever comes in your mind first, you can write in that, but it does not matter. But the angle that you want, in which the main angle is drawn, that one needs to be in the center, right? So I am considering with ABC, right? So, and I have drawn a arc. I have drawn a common arc here, right? Which divides the angle ABC in two different angles. So by drawing this, what happens? I have divided this bigger angle into two parts. Now two equal parts or not, that is different. When this would have been two equal parts, that I'll explain again afterwards. When I'll come to angle bisector, then I'll explain you, right? So here this is just a arc which divides the angles in two parts, right? So what are the two parts? First, when this arc was not there, BD, the angle was only one single angle, ABC. Now because we have drawn this line, now what happens? This one bigger one has been divided into two areas. One is this, another one is this. All right, one is this angle, another one is this angle, right? So now when I talk about this, now this angle is known as what? Angle AC. This angle, no, it's divided in two parts, but is its vertex changing? No. Is this angle's vertex changing? The center angle, is it changing? No, it is still in the vertex B. So angle AB, just it's one of the vertex is changing, that is, instead of C now it is D, because its arc is changing, but the angle on which it is same, just that the angle is becoming a bit smaller. Alright, now when I talk about this one, here also one of the arc is changing. Instead of A, it is angle DBC. Again here, see, here also the main angle was B, and the main angle is only divided into two parts. So the main angle will still be in center. The main angle will still remain the main angle, right? ABC was the bigger angle. I have divided that in two parts. Still that one will be in because the base of the angle is not changing. On which it is still there. Is just that it has been divided in two parts. So DBC. So this is your second angle, right? Now we can tell that angle ABD and angle DBC are adjacent angle. Okay, now what are the criteria you can notice, so that we can call this two angle as angle ABD, angle DBC. Now are adjacent angle. Now what are the criteria you can see, so that we can tell that these two angles are adjacent angles? क्या criteria है? First one is this, isn't it? ABD DBC. Now what are we saying? That the main angle is divided into two angles by a common arm. This is a common arm which divides. So DB is a common arm which divides the angle, the main center angle, in two parts. So for any angle to be adjacent angle, you have to see that there is a common arm which divides the two angles. So one criteria is what? Common arm divides the angle in two parts. This is the first criteria for what? Adjacent angle. You don't have to mug up the criteria. See, you can clearly see DB was the common arm which is dividing the angles in two parts, the main angle in two parts, right? This is the first criteria. You don't need to mug up the criteria, just yours, and I'm making you visualize how it is coming. Now next, the base of the angle remains the same. I've told you again, isn't it? The main angle was ABC. Even after dividing B and B, the base of both the angles remains the same. Alright, so this too is more than sufficient to identify whether the angle is adjacent or not. There is always an arm which divides in two parts. Alright, which divides the angles in two parts, and what? The vertex, the base or the vertex remains the same for both the angles, right? It remains same for both the angles. So these are the criteria. So now in this, on the basis of this two, we can tell that yes, angle ABD and angle DBC are adjacent angles. So this was adjacent angle. Next we'll discuss about your linear pair, right? Okay, so now linear pair. Alright, let's draw an angle. What do you understand by linear pair? Alright, suppose this is a line on which another line is intersecting. So what happens now? There are two angles that has been created. When we draw, suppose AB, we drop a line CD, and the line CD intersects the line AB at D. At this point, it is intersecting at this point. So at this point, there are two angles that are forming, this and this. So what are these two angles? Two different areas, right? Two different arcs. So what, this side we can call it as angle ADC, or because the angle is on because the angle is in vertex D, so we have to keep the vertex D in the center always. Or you can even call this as angle CDA, but that D does, the position of D will never change, because this is the vertex on which D angle is present, isn't it? And this one you can call it as angle CDB, or even angle BDC, whichever comes to your mind first, but you have to make sure that on whichever vertex the angle is present, that has to be written in between. So in this both, the angle was divided in two parts. Alright, so and in both the angles are present in the common vertex D, right? Now we know now, if the angle, we know straight angle in 6 also we have studied, this is present here. This angle is known as straight angle because it is making a semicircle and it makes an angle of 180 degree. So isn't this very similar to straight angle? It's just that instead of making a perfect semicircle, but how do we, on the basis of semicircle, we consider an angle as 180 degree? No. What is the main logic behind considering an angle as 180 degree? We have to see that on a straight line, if an arc on a straight line starts from, if an arc on any straight line starts from a point and ends also in that same straight line, then we can tell that yes, the angle is 180 degree. What do I mean by that? See, in the line AB, the arc is starting here, right? This arc is starting here, and now is this arc finishing? The same arc is finishing. Yes, is instead of I could have drawn this one like this also, but instead of connecting it together, I have just I've extended it from here. But it's an extension of the same arc. This one is the extension of the same arc, just from the different position, and it is coming and meeting at the same straight line AB. That means yes, it is making a semicircle. Since it is making a semicircle, so I can tell this angle plus this angle will together give me a total value of 180 degree. So what can I tell? So instead of taking both, I have shown you can write in both way, but I'll consider one. Let's take this. Alright, you can take the other two as well, no problem, whichever strikes your mind first. So what we can tell? So this angle ADC plus angle CDB. This angle, that means CDA or ADC and CDB or BDC, whichever, when these two are, I don't know their exact value, that will, if that is given in the question, fine, but one definite conclusion can be derived from this, that when this angle and this angle, they are added together, they will give me a result of 180 degree, because I know these two angles together is making a semicircle, and semicircle means it's making a straight angle which is equivalent to 180 degree. So on that basis we can tell that this angle and this angle, when joined together, their sum will give me 180 degree, and this property is known as linear pair. So these two angles together is known as linear pair. So for example, this value was given to me as 70 degree, right? They would have asked me find the angle, they would have given CDA equals to 70 degree, find the angle CDB. So using which theorem or which property we could have found this value? Clear, right? Now I hope you all can calculate and find it, because if CDA is given to me as 70, then I know that when CDA and CDB, when both of them are combined, when this and this angle both of them are combined, it gives me 180 degree. Out of that, one contribution is given to us. How much does this angle contribute? 70. So how much will this contribute, so that together they can make up 180 degree? So how do I find that? I'll keep this here, CDB equals to 180 degree. Whichever angle you need to find out, keep that as subject. I'll keep this one this side alone. Isn't it that I've been explaining in every chapter almost, wherever it is possible to keep as subject? Whichever you want, you'll keep that as subject. And now you'll send this one this side, 180 minus 70. So it gives you 110. So the other angle's contribution is 100. If this was asked, then this contribution is 110 degree. So this is the linear pair. Okay, so now next we'll study about a different type of angle, which is known as vertically opposite angle. This one is very easy, right? Now for example, one line is here, another line is something like this. All right, this line is your AB, this line is your CD. All right, line segment, because it has a finishing and starting point, AB and CD. Now for example, now what are the angles being created here? For example, this is the intersection point of both the lines. Intersection points means where the two lines meet each other. So this is the point where the two lines AB and CD are meeting. So I'll take this line, I'll give this line, this point, a common name as O. It's a common point, right, for all the four angles that are being created. So one angle is this, another angle is this. One angle is this, another angle is this. Alright. Now what is the name of this angle? It's present in this arc, right? So AOC. Angle AOC. What is the name of this one? It's, see, you're seeing one thing. All the four angles are present in the same vertex, that is O. So what is this arc? C, angle COB, or you could have even named this as BOC. I'm not writing it, but since I've explained you again this one, you could have named this as COA. It's same thing. Alright, does not matter. This one you can name it as angle DOB, this arc, or BOD, same thing. And this one, it's AOD, angle AOD, or you could have even given this as this a name as DOA. Does not matter, right? But O, see, since O was the common vertex for all the angles, so in each and every case, no matter whichever name you select for this, either AOC or COA, you will find that O in each case will remain as the main angle, the center angle, because this is the vertex on which all the four angles are made. Now this is vertically opposite angle. Now vertically opposite means diagonally, if two lines are created, then the top, bottom and left, right are equal angles. What do I mean by this? That means this angle and this angle are vertically opposite to each other, and this angle and this angle, which are drawn in two pinks, are the opposite angle to each other. Now what is the relation between two opposite angles? They are equal. Therefore, what are the conclusions I can write? Angle AOC equals to angle DOB. So this is one thing we can tell about the pair of opposite angles present in this figure, AOC and DOB. Similarly, what we can tell, the other set of this here vertically opposite angles are also equal. Now what are the other pair of opposite angle? Angle AOD. Angle AOD equals to angle COB. So in this case, these two opposite angles are equal. So this was all about vertically opposite angle. Alright, so now last two types of angles are left, and after that we'll be done with all the concepts related to this chapter, and then we can directly dive into the question part. Alright, now the two angles that are left are complementary angles. Alright, now what do you understand by complementary angles? The two given angles, two given angles are complementary angle if their sum gives us 90 degree. For example, if someone tells us angle ABC and angle BDO, these two angles are complement to each other. Now what do I understand by this statement? This angle and this angle are complement to each other. By hearing this statement that these two are complement to each other, the basic thing that would strike my mind is that, okay, these two are complement to each other. That means when I add the value of this angle and the value of this angle, their sum will give me as 90 degree. So angle ABC plus angle BDO. Now I have taken their sum. I don't know the individual value, but what do I know? That their sum, when I add both of them together, this will definitely give me 90 degree. Now if out of this one angle is given to me as 40 degree, find the complement of angle ABC. That means indirectly they are asking you find the value of angle BDO, because these two are complement to each other, and out of that one angle is 40 degree. Therefore automatically what will be angle BDO? Angle BDO. What will be angle BDO? keep this as subject, 90 minus 40, alright, which is given to us, that is 50 degree. So what is the complement of angle ABC? Complement of angle ABC is angle BDO, which is equal to 50 degree. Alright, so this is complementary angles. The sum is 90 degree. Final one is supplementary angles. Now very similar to complementary, the statement that I had given, when two, in complementary the statement was when two angles are given to us that they are complementary, then what can we conclude? Their sum will give us 90 degree. And in supplementary, when two angles are in supplement to each other, that means their sum will give us 180 degree. This is the basic difference. For example, the angle given to us are angle ABC and angle PQR. These two are the angle given to us. So what are the definite conclusion? What is the definite conclusion that I can derive from this? So these two angles are, and this are supplement to each other. They have been given to us, right? This has been given to us. So what conclusion, what definite conclusion can be derived from this? Angle, when I add the sum of this angle and the sum of, and the value of, sorry, not sum, the value of this angle, when the value of angle ABC and the value of angle PQR are added, their sum is definitely going to give us 180 degree. So when these two angles are given to us as supplementary angle, then the sum of the value of their angles will give us 180 degree, or the individual value of both the angles when added together gives us 180 degree. This is your supplementary angle. Okay, alright. So now one thing I had missed out, I'll tell you that what it is. It's degree, minutes and seconds. Now how are they related to each other? I'll give you with, again I'll explain this concept with a basic example, right? Degree. Now for example, I have 90 degree in hand. Alright, how can I express 90 degree into minutes? Alright, how can I express 90 degree, how can I write 90 degree in minutes? So what you'll do, you'll always take 1 degree aside and keep the remaining degree as it is. So 90 degree, to express it in minute, what you'll do, you'll write it as 89 degree. You will subtract 1 degree from here, because this 1 degree you will convert into minutes. Alright, and 1 degree, what is the relation between 1 degree and minute? 1 degree is equivalent to 60 minutes. So basically you know the relation between hour, minutes and seconds. Hour, minute and seconds. So in this case, instead of hour we are writing degree. That's it. There is nothing new in this. Instead of hour we are using degree. Alright, since 1 hour equals to 60 minutes, so instead of 1 hour you will consider 1 degree equals to 60 minutes. If you know the conversion between hour, minute and seconds, that's it. There is nothing more in this. So you know, if you know degree, so consider this as 90 hours. Now you have to consider 90 hours in minutes. You have to write 90 hours into, you have to consider in a minute also. What you'll do, you'll break that, you'll only give 1 hour borona, rest you'll write 89 degree as it is. That 1 degree, that 1 hour will be converted into how many minutes? So 1 degree, 1 hour equals to 60 minutes. So similarly here, 1 degree equals to 60 minutes. So 89 degree plus 60 minutes, and this is the sign of minutes here. Single dash on the head is known as minutes. So we have 90, we have written it as 89 degree plus 1 degree. We can write 90 as 89 plus 1. So 89 we write as it is, and 1 degree is converted into minutes. Okay. Now if we want to break down this minutes into seconds also, now I want you to write down in seconds also. So before converting into seconds, First my job is to convert into minutes. So do I have in minutes? Yes, I have how many minutes here? 1 hour equals to 60 minutes na? So 1 degree equals to, we have 60 minutes here. Now we have to write this minutes into seconds. Now do we need to change the entire minute part? No, just like to convert into a degree into minute, we only give one, right? We only give 1 degree and convert it into minutes. So similarly here also this will remain unchanged, because we have already made a change here to convert it into minutes. Now it's whose time to sacrifice? Minutes time. What is the process? Same process as how the degree sacrificed. It only it gave its 1. So similarly 60 minutes, I don't need entire 60 minutes to convert into seconds. Out of this 59 will remain. Again 60 minutes can be written as 59 plus 1. 59, the majority part of it, 59 will be written as it is. Now next it's time for this 1 minute, like it was time for this 1 degree to convert into 60 minutes, it is time for this 1 minute to convert into seconds. And what is the relation between 1 minute and seconds? 1 minute equals to 60 seconds, we know that na? So this is minute plus, we have written this 60 minute as 59 minutes plus 1 minute. So this one will be written as it is, just like this one, it came here. And this 1 minute will be converted into how many seconds? 60. And what is the process of writing second? Because since we are not using directly second, so we will not write S. We will denote here, second is denoted by double dash. Minute is denoted by single dash. When you see this, you know it is minute. When you see double dash, you know it is how much? Seconds. So this is how you convert minute to second. Slowly write this process in this way only, it will be very easy for you all to remember, and to convert in many questions you will find this as well, and in exam also 1 or 2 questions you will get of this, consisting of 2 marks each. Alright, so this was all about it. Thank you. Alright students, so this was the concept, the entire concept which was there in this chapter, and in next part 2, we will discuss few problems related to this chapter from the same book. Thank you.